Guys, I welcome you all for today's video and today's video about the data science and its application. Here we'll be discussing about the continuous distribution, normal distribution, then CLT, then p-values and confidence intervals. So I am Lakshmi Vaibhavi NV, currently pursuing a BE in CSC AI at Shiving College of Engineering. So guys, let's get into the topic. First we'll be having the continuous what is this continuous distribution? A continuous distribution is a statistical and a mathematical concept that applies the set of data or variables that can take any values within a given range. Nothing but like you provide a range, this range, then you provide a data set, and this data set can distribute among this range of the data range or this given range. That means the variables can assume the infinite number of values within a certain bounds, and continuous distribution constraints with a discrete distribution wherein the values can only be distinct and countable. The concept is crucial in the probability theory, statistical, as it helps in modeling various real-world phenomena where the outcomes flow to an unbroken range. Next, we will be having the normal distribution. Normal distribution is also known as the Gaussian distribution. It's also a type of continuous distribution. It is characterized with its the bell shape where it is symmetric around the mean. The first thing is normal distribution has several important properties, and it makes the fundamental concept in statistics and the probability. Next is, as I said, there are some terms that is these are symmetric around the mean. So what is this mean? What is this asymmetric? Let's look into it. Symmetric, the distribution is symmetric about the mean, meaning that symmetric is nothing but the left, the half of the image is like it is identical to the right half, right? It is symmetric. Means it is mirroring the same effect here also. So this is called as symmetric images. If there is any variation between the left image and the right image, we'll call it as an asymmetric. This is a simple difference, guys. The second thing is mean, median, mode. Uh, this for a normal distribution, so don't get a difference between mean, median, and mode. These are equal and located at the center of the center points of the distribution. Next is standard deviation. The spread of the distribution is determined by its standard deviation. A larger standard deviation results in a wider and a flatter curve, while the smaller distribution, this in standard deviation, it results in a narrower or a taller curve. Next is asymptotic. The tails of the normal distribution approach but never touch or means it doesn't touch the horizontal axis. So let me show here. It doesn't touch the horizontal axis. This is called an asymptotic. Um, what asymptotic distribution. This means that there is no non-zero probability of all real numbers, but a probability decreases as you move further from the mean. Next is CLT. CLT is a statistical concept that describes the behavior of the mean of the random sample drawn from the distribution. The distribution of the sample means root is a normal distribution. As the sample size grows, regardless of its initial population distribution shape. In other words, sample mean is normally distributed regardless of the underlying population distribution. So this image relates to the central limit theorem. If the sample size is bigger, then the distribution averages more normal and more deviation. The CLT is based on the three main assumptions. One is independent, means the data points in the CLT is independent. Randomness, so it shouldn't be the same. There should be random it should there should be an entropy among the data sets. Next is sample size. It should be sufficiently large. Means usually it always the n values or the sample size is always greater than 30. Next is sample statistics. One of the application in estimating the population parameters is the sample statistics. For examples, like if you want to have interest in the estimating the average height of the population, so we can take a random samples, we can collect the data from the random individuals and use the data for it can be used in the CLT to estimate the population means with a higher degree of accuracy. The main application is the CLT is for the accuracy. Next is confidence intervals and margin of error. Confidence intervals and margin of error are also important applications of the CLT. A range of values known as the confidence intervals will likely include the population parameter of the interest. The degree of the mistakes we are prepared to accept when estimating the population parameter is known as the margin of error we accept. Next is both the confidence interval and the margin errors are, these are affected by one is the sample size, then CLT. So mainly it gets affected by the sample size, and the CLT plays a crucial role in determining the appropriate sample size for the accurate estimates. Next is hypothesis testing and a p-value. Defining the hypothesis testing. Like if you say if it is raining today, the opposite to that, how you're gonna test? Like you say it isn't raining today. So this is the hypothesis testing. Hypothesis testing is a statistical method that is used to make a statistical decision using experimental data. The hypothesis testing is basically an assumption that we make about a population parameter. It evaluates two mutually exclusive statements about a population to determine which statement is supported by the sample data. Like if you say if it is raining today, these statements can be like if I give you an example, it is sunny today, it is cloudy today, it is bit drizzling today. So which statement supports to your statement or which is complement to your statement? We uh, we take it as a supportive statement to your sample data. Next is understanding the p-values. The p-value is a number of calculated is a number that is calculated from a statistical test that describes how likely you are have you are to have found a particular set of observation if the null hypothesis were true. If it isn't true, we'll go for an the other ways. How are you going to interpret the p-values? P-values are the probability of observing a sample statistics that is at least as extreme as your sample statistics when you assume that the null hypothesis is true. What is null hypothesis? As I said, like if the hypothesis is it is raining today, then the null hypothesis is it is not raining. Means the exactly opposite to your hypothesis. Which is confidence interval. I'm sorry, Russ. Confidence intervals are the statistical concept used to to estimate the range within which a population parameter, such as mean or a proportion, is likely to lie. Means confidence interval means like if you got a statement uh, within which range your statement lies. So they provide a range of values that are believed to contain the true value of the parameter with a certain level of the confidence. Like how this confidence intervals work. First thing is estimation. Start with a point estimate of the population parameter based on the sample data. For example, if you are estimating the populating mean, your point estimate might be the sample. Next is you're going to find the interval calculation. Use the point estimate and margin of the error to construct the confidence interval. The confidence interval is typically expressed as first thing is interpretation. Then margin of error interpretation, like for example, your confidence interval is 95% of the population for the population mean. It means that you have to take many samples and you have to calculate the confidence intervals from each one. So the expected interval is no the expected true population mean is like when it is 95%, the expected mean also should be the 95% true. Next is margin of error. Calculate the margin of error, which represents the amount by which point estimate might differ from the from the true population parameter. This is typically based on the variability of the sample data or the desired level of confidence. Means if it is any variation or if it is any deviation from your data, it might it is expected to get entropies or some the slight errors or the slight uh, you know devalues in the confidence apart from your desired level. So this is the concept for today, and thank you guys.